This might be the easiest lesson out of all of the lessons, but for some reason, some people still struggle with it. Not a ton, just a couple. The hardest part of this should literally be memorizing those lovely little formulas. But I already told you I'm going to give them to you because I'm nice. I'm not giving you anything else, but I'm giving you that. Okay. So if I want sine neg 1 of 4x squared, the sine neg 1 formula is this. Sine neg 1 of x, I go 1 over the square root of 1 minus x squared. Do you agree? It's just the formula. That's what we're going to use. So if I want sine neg 1 of x, x just happens to not be x this time. What is x actually? What is x? What is x? Yeah. Thank you. It's 4x squared, which means instead of having an x, I'm going to put a 4x squared in where the x would be. Okay? So our formula is 1 over the square root of 1 minus x squared. So y prime equals 1 over the square root of 1 minus x squared. X just happens to be 4x squared. Now that is the actual way to do the derivative of this, correct? To do the derivative of sine neg 1. Now, we have to actually multiply behind by the derivative of 4x squared. But that's not because of the sine neg 1 rule. It's because of what rule that we learned? Chain rule. Chain rule states that at the end you have to have actually taken the derivative of everything, correct? And currently we have not taken the derivative of 4x squared, yes? So we have to multiply behind by 8x. And that 8x is over 1, correct? So the 8x can just join the top. So y prime equals 1 times 8x, which is 8x, over the square root of 1 minus, what do we do here? You have to remember to square both of the things, right? The 4 and the x squared. 4 squared is 16. X squared squared is x to the 4, and you're done. So the original is literally just using the formula and putting in for x, correct? And then if it's not just an x, you actually have to chain rule because of the rule of chain rule, where you have to actually do the derivative of everything. Now b is y equals e sine neg 1x. So is this more of a sine neg 1 question, or is this more of a numerical base to a variable exponent question? Numerical base to a variable exponent question. Yes? Happens to just have a sine neg 1 in there, but it's a numerical base to variable exponent. So we have to, what's our steps when that happens? Rewrite it. Then on the base, which is e, so it becomes a 1, and then the derivative of the exponent, which is the derivative of sine neg 1x, correct? Which is off of a formula sheet. 1 over the square root of 1 minus x squared. So I technically have, I'm super boring someone just made a master yet. E sine x times 1 over the square root of 1 minus x squared. Now remember, with fractions, we have to multiply numerator times numerator, denominator times denominator, yes? So if you just have a numerator, your denominator is 1. So can this not just join the top and that just join the bottom and call it a day? Yeah. Like I said, I don't want to assume things, but when I write something down, I assume you're writing it the same, right? So when I look at some people's papers, they don't have a y prime or an equal sign to be found. Like I'm like searching with a magnifying glass, can't find them. So if I'm writing them, you have to write them.
And I did.
The person who I think would have it most would be, starts with K, rhymes with Schmeil. Yes, it does. Schmeil, Schmeil, same thing. One syllable. Okay. I want you guys to try these out and see how you do. Go. Try them out. 10 neg 1. You don't have to memorize. You can just find it. It's 1 over 1 plus x squared. So we're going to get 1 over 1 plus x. Happens to be a 4x squared. And then I have to remember to multiply by what, people? 4. And so then that is 4 over 1. So the 4 can join the top, this can join the bottom, and I get 4 over 1 plus 4x squared. This is, that could be 16. Try again, Lepp. All right, 16x squared. Now, this question was a straight up inverse question first, right? We had an inverse question, then we had a straight up numerical base variable exponent question, which had an inverse in it. Straight up inverse question. What is B? Is it a straight up inverse question? No, it's a chain. It's a trig with a chain that would chain out an inverse. That's exactly what it is. So, what's the derivative of sine? Cos. And then do I immediately go right to the derivative? No, what's the rule? You derive the outside, rewrite the inside, follow behind with the derivative of the inside, correct? I get tons of people on your unit exams that will go cos and then immediately do the derivative in the brackets. That's not what we need, right? We need derivative of the outside, rewrite the inside, times the derivative of the inside. This is over 1, rewrite it. Y prime, cos, tan neg 1x over 1 plus x squared. Okay, then flip over. That is literally all that there is to that. That is it. The hardest part is memorizing the table, which I'm not making you do. You're welcome. It's a gift. You know? Like my class. Like great gift. All right. So this is the last thing we're going to go through before your test. So there is logarithmic differentiation, but it's being taught on Thursday. That's on Wednesday. It's not on. Obviously. Okay? So your text is next Wednesday. That scares me that you didn't know that. Okay. So derivative of lns and logs. Derivatives of lns and logs follow the same rules. If you do the derivative of a log or a ln is just what? Log base e. Nothing different, right? It's still a log, is it not? It's a natural log, log base e. When you do the derivative of a log, what you do, paying attention, is you do whatever's beside the log goes in the base, so x, ln the base, and then there's a 1 on top. Now, what happens if this isn't just an x? What if it's a 3x? What would I multiply by? What would I multiply by? It's a 3x. I would multiply by 3 because chain rule states I have to multiply by all the derivatives, correct? So if when you have a log, you go 1 over whatever's beside the log, ln of the base, and then you multiply by the derivative of what the heck's there because we haven't done the derivative of it. Chain rule. Okay? So let's look at some of these. Differentiating log functions. Find y prime if y equals ln x. Now, is this a ln question or a chain rule question? What do we have to do first? Chain rule. So it's a chain rule question with a ln in it, right? So essentially we have to chain first, then ln. Okay? So let's pay attention. Because these are once again easy, but you can get lost because it's all brand new. Okay? So we have a 2 on the outside. We drop the 2 in front. Then what do? Ln x. Rewrite it to the 1. That looks like an alpha. It's supposed to be an x. Okay? Then we have to follow behind by the derivative of ln x. I'm going to do it up here just so you can see. So ln x is the same as what? You're giving me the derivative. I want to know what ln x is. We haven't even gotten there. Ln x is log base e of x. We agree? So now I'm really trying to find the derivative of log base e of x. Yes? Everyone paying attention? Whenever I have a log, the way I find the derivative is I do a 1 in the numerator over what's beside the log? What's beside the log? X. Right? Then I follow behind with ln of the base. What's the base? E. And what is ln e? 1. And then I have to multiply by the derivative of x, which is 1. So that's why it actually is just 1 over x, because the ln e cancels and the derivative of x is 1. Okay? So if it's a basic ln, so here we have 2 ln x to the 1. We need the derivative of ln x. It's 1 over x. What are these over? They're over 1. I don't know where my red went, but it left. So now we have 2 ln x times 1, so 2 ln x over x. Now some people want to try and cross those x's off. This x is embedded in a log. Can you cross them off? No, that would be silly. Not going to do that. Okay. Logs with no base. Not a ln with no base. Logs with no base are base what? Every single one of you knows. 10. It's like in your soul. It's been taught to you. So we can rewrite this as 1/2 log base 10 of x. So if I want to do y prime, what did I tell you? If there's a coefficient, what do we do with the coefficient? Just comes along for the ride, correct? So if there's a coefficient, it just comes down. So I'm going to get 1/2, and then I have to do the derivative of log base 10 of x. So it's a derivative of a log. So I write a 1 in the numerator. In the denominator, I write what's beside my log. What is beside my log? An x. Then I have to follow beside with ln of the base. What's the base? 10. You have to write that, because ln 10 doesn't go away. That's log base e of 10. It's just a decimal. And then I would technically have to multiply it by what's in this little bracket, right? Which is just a 1, so it doesn't really do anything. Because you have to chain behind, right? But the derivative of x is 1. Because we didn't do the derivative of x. We just rewrote it down here, ln the base, and we have to multiply by the derivative of x, which is 1. So we end up with 1 over 2x ln 10. What is C? It has some lns, but what is the actual lesson we're doing? Implicit differentiation, because we have x's and we have y's. Yes? Yes. Okay, let's see how we do. So ln of x is the same as what for a derivative? 1 over x. And why is it? We're going to show all the work, because when we show all the work, we won't screw up when it's not just. So this is the same as, I'm going to prove my point. I don't even know what is going on. There was a recall for something. I don't know. Okay. Log base e of x plus log base e of y. I'm doing this to prove a point equals 2x. And why am I doing this to prove a point? Because I don't want you guys memorizing bad things. I don't want you to be like, oh, the ln doesn't go on the bottom because when it's a base e, I just have to write it. No, you don't not have to write it. Ln e is 1. That's why you don't write it. It's not because you just don't have to, right? So what do I do when it's a log? I put a 1 in the numerator. I put this in the denominator. Then I go ln of e. And then I have to multiply by what? The derivative of x, which is 1 plus. Now if I do log base e of y, I get 1 over y, ln the base, ln e, and then what do I have to multiply by? The derivative of y, which is either dy dx or y prime. They're asking for y prime, so I'm going to use y prime. And then it equals what? What's the derivative of 2x? 2. So we're going to simplify this because ln e is just 1. So those are, why did it go away? I had it right. Oh, here. Whatever. Didn't want it read anyways. Thanks, board. 1 over x plus 1 over y prime equals 2. So how do I get y prime by itself? Subtract the 1 over x. And then how do I get the y prime by itself? Do it all answer at once. Multiply by y. Red just comes back every so. Now, that could be the answer, or they might make a common denominator and then put the y in, right? How do we make a common denominator? I put this over x. Can I just randomly put something over x and be like, good? If I put an x in the denominator, I have to put an x in the numerator because x divided by x is 1. And when I multiply by 1, what happens? When you multiply by 1, what happens? Starts with an n. Rhymes with nothing. Nothing, which is what you want. Because if you change it, we have to multiply by an x over an x, because x over x is 1. And multiplying by 1 is not going to change my equation, right? That's why you always multiply by the numerator and the denominator. Because 1 over, or x over x is 1, multiplying by 1 doesn't change your equation. So now we have y prime equals 2x minus 1 over x times y. And then I get the people who, and there's more of you than you think. You'd be like, nah, I don't want to do that. You're like, I don't know if the y is the numerator or the denominator or both. You're multiplying fractions, correct? When you multiply fractions, numerator times numerator, denominator times denominator. If it's stressful to you, you don't know where that y goes, make it have a denominator. Currently, it doesn't have one. What is its denominator if I want to give it one? 1. So numerator times numerator, denominator times denominator, then it's much more obvious that the y only joins the top. So we get y prime equals y, bracket 2x minus 1 over x. Now this one, is the x cubed or the log base 2x cubed? D, is the x cubed or is the log base 2 of x all cubed? The x is cubed. If the log was cubed, there'd be brackets around it. So to make it better for you, if you'd like, do that. Try that one out. So this one, y prime equals 1 x cubed in the denominator, ln of 2, the base, and the derivative of x cubed, which is 3x squared, over 1. It'll join the numerator. And so we're left with 3x squared over x cubed ln 2. And that won't be the answer they're going to give you because they're going to cancel that and 2 of those. So they're actually going to give 3 over x ln 2.
Now, how did you do that?
No, it's not. Okay. Then we have ln of 5x, which is the same as log base e of 5x. And whenever we get a log, that's just y, that's not y prime. We will put 1 over whatever's beside the log, 5x, ln the base, so ln of e, which happens to be 1, times the derivative of the inside, which is 5 because of chain rule. The 5 will join the top, so I'll get y prime equals 5 over 5x. The 5's cancel, and I'm left with 1 over x. B is a what rule? What is B? You'll need a chain rule eventually, but it is product rule, right? F, G. So y prime equals G times f prime, which is a 1, plus f times g prime, which is x squared ln of e with a 1 times the derivative of the inside, which is 2x. So you have to remember when you have two variables, you product rule. Product rule is very important. People forget product rule. They'll just do 1 times the derivative of ln. You have to do gf prime plus ft prime. So then I'm going to get ln of x squared plus 1 plus x times 1 times 2x is 2x squared over 1 times x squared times 1 is x squared. Those cancel off. And I'm just left with ln x squared plus 1 plus 2. Okay? In Google Classroom, I posted 2 little assignment things. There's an assignment, answer key, assignment, answer key. So the first assignment is trig derivatives, or trig inverse trig derivatives. And then the second one is log derivatives. You have to do 1 A to H for both. You have about 20 minutes. These are not super hard ones that I picked. So if you actually work, you should be close to completing them. If you choose to do them at a later time because you want to work through your assignment and ask me questions, power to you. You make the choices. But it is still due.
When is it?